In this video, we want to talk about complex number. You know what complex number means is when we have one real number and one imaginary number. Imaginary number means that when we want to talk about a number that has I, J, or K, in such a way we have in factor. You know, when we want to represent the unit vector, we can have unit vector of like one unit vector I, 3 of J, and 4 of K, and so on and so forth like that. Now, and I said that, let's take an example. Let's say we want to talk about square root of 4. You know it's going to be plus minus 2, and that of 9 is going to be plus minus 3. But when we want to talk about minus 4, we are going to have something I or J. So when we have things like this, it is what we call complex number. Meaning this I is based on complex number. It can be I, it can be J, it can be K as well. You can use any of the representation. You can use I or J like this. So now let's go back to this. In complex number, when we have I square or J square or K square, means I times I or J times J or K times K, it's going to be automatically minus 1. That is the rule. So when we have I cube, we're going to have I times I times I. You know I square is minus 1. This one is going to be I square multiplied by 1. You know this one is used by 1. So 1 plus this is going to be 3 using the rule of indices. So this one is going to be minus 1 multiplied by J. So you have minus I or minus J. So I raised to power 4, we have I square multiplied by I square. So we have this minus 1, that's minus 1. Then we have minus plus 1. So I raised to power 5 is going to be I raised to power 4 multiplied by what? I raised to power 1. Using the rule of indices, you now have 1. You know this one is 1 already. Multiplied by this I, we have I. I raised to power 6 is going to be minus 1 using the rule. Now when we want to talk about negative power, negative integer powers, negative integer power, you know I square, we said it is minus 1. But we now divide you by I square, I or J. If it can be J square as well. You know I said they are the same thing. Probably I'm going to change it in the long run. So when dividing this one is going to be I square over I. This one over I as well. So I, it remains I here. And this one is minus 1 I. The same thing as this. You can write your factor as I. You can write the factor as I, normal I like this. Or you write it as this. You can write your J as this or J as this. You can write your K as this or K as this. So they are the same thing. So when I was putting this caveat on it, it doesn't mean that it's not correct. It is the same thing. I hope you understand what I meant. So the next one, you know this one is going to be 1 over this. So this is going to be raised to power minus 1. So it means that this I, inverse of it, like negative power, is going to be I. So now finding raised to power minus 2. You know, this one is going to be raised to power minus 2 minus 1. I've been like raised to power 2 minus 1. Then we have this raised to power 2 already. You know, this is J. So J raised I raised to power 2 or J raised to power 2 is 1, minus 1 already. From this, you know it is minus 1. So this one is minus 1 raised to power minus 1. We now have minus 1 over 1. We now have minus 1. I hope you understand this. Now, J is minus 3. This one, which is minus 3, is going to be raised to power minus 2 raised to power minus 1. Should be now. You know when we want to add this using the indices, we are going to take this one as the base and add the power. So this one is minus 1 already. J raised to power minus 2 is minus 1. And this one is minus I. So this one is already minus 1 multiplied minus I, now have I. I raised to power minus 4, J raised to power minus 4 is going to be raised to power minus 2 all square multiplied by 2. So we have J raised to power minus 2 to be what? Minus 1. From this, you know it is minus 1. So now continue with this, we have minus 1 all square. This all square, put it here, we have 1. Raised to power minus 5, the same thing. So you have minus this. Now note that this I can also be written as J as in form of K as well. You know I already explained it. Using all this, it can be done this way. Note, the word complex means complicated or mixture. When something means complex, it means it is complicated or what? Mixture. I hope you understand this. Now let's go to the addition and subtraction of our complex number. When we want to add addition and subtraction of a complex number, they said we should simplify the following. You know, when we want to pronounce it, they are going to call this one 4I plus 5J plus 3 minus 2J. So we want to divide this. You know, this one is addition. This addition is going to open this bracket and it does A. So we have 3I. You know, this one we are going to add this. And one rule is in complex number. When you want to add or subtract complex number, you must add the one that is imaginary and minus or subtract the one that is real. That's the rule. So this one, 4 and 3 here, they are the real numbers. You add them. 3 plus 4 is 7. The imaginary one here is 5 and 2. So you subtract 2 from 5, then you have 3. That's the answer. So the second one, they said we should find 4i. So this is number 2. You know, you are going to use this minus to open this bracket. When you do, you are going to subtract the ones that subtract and you add the one you get. So you find the answer. This one same as applies to this as well. You are going to use minus to open this bracket, this plus to open this bracket. Then you add the real numbers and you add the imaginary number. Then you have this 4 plus I. You know this one, this I is 1i, so you have just 1i or j or whatever. So use this one to open the bracket as well, the minus or the plus as well. So you get the answer. So multiplication 1. When you want to do the multiplication of complex number, in multiplication of complex number, you are going to use, let me give an example. Look at this question. You are going to use this one, this 3 to multiply these 2 and this id. You are going to use j4 to multiply these 2 and j5. So using this, you are going to use 3 times 2 is 6, 3 times 5 15i, 4j times this is 4j. We have I times j, we have j square. 4 times 5 we have 20. You know j square is what? Minus 1 from the real main. From this I square or j square. You know I said this is minus 1 from this. So this one is minus 1. So that's why you have minus 1. I hope you highlight it here. So you get the answer. The same way you are going to use to calculate this. The same way you are going to calculate this as well. So now let's go to conjugate of the complex number. When you want to talk about the conjugate of the complex number, more or less like when to talk about the conjugate of a sword. The conjugate of this, the only thing you are going to use in conjugate is that you just change the sign. 4 plus j5, it is 4 minus j5. A plus jb, it is going to be minus. This one is going to be plus to minus. This one minus to plus. So multiplication of the conjugate. When you multiply conjugate, let's give an example. Let's say you multiply this. This one times this one. You know this one multiplied by this is going to bracket. This 4 is going to multiply this 2. This j3 is going to multiply this 2 as well. I hope you understand what I said. From where I explain multiplication of complex number, I hope you understand it. So now let's go back to this. So this one, when this one multiply this, you have 12. This one is going to be 12j. This one is going to be 12j as well. And this one is going to be 9 minus 9 square j. So it's going to be 25. One of the things I want you all to understand is that, okay, let me do the second one. This is number 2. This is number 2. So I, x plus jy and this. This x is going to multiply this 2. This jy is going to multiply this 2. So when we have this, you must understand something like that. The moment you multiply the conjugate, we do cancel the one that has I or jjj. The one you used to represent it. It depends on you. And it will only end up having only a real number. So it means that when you are multiplying conjugates of when we multiply a conjugate of any complex number, we only have only real numbers. We don't have complex number. Now this is the third one. When you do the conjugate, you get the answer. So I write it here. When multiplying conjugate, we only have complex. We don't have the complex number. We only have the real numbers. That's all. Division of complex number. There are two types of division. We have division of complex number by real numbers, and one of a complex number. So the one with example, when we want to talk about the one with real numbers. So 5 minus j5, j4 over 2. So this one is 5 over 2 minus this over 2. So just put on in decimal times. So I hope you understand it. But the one with complex number, division of complex number by a complex number. One of the things we do there is that, you know, this one is going to be in form of denominator. This one is going to be numerator and denominator. And we want to find the conjugate. Conjugate, you are going to find the conjugate of this. Then multiply the conjugate by the numerator and denominator. That's what we do. So you know the conjugate of this 1 plus j2 is going to be 1 minus j2. So you now multiply this by 1 minus j2. Multiply this by 1 plus j2. More or less like you are doing for sword. So this one is this. So I hope you understand it. When you do the conjugate, you're going to get this. So one of those things you must know is that when you multiply the conjugate, you only have only real numbers, not words. I hope you understand it. So divided by this, so you get the answer. Same way we are going to do the second one and the third one as well. I hope you understand all this. Now, equal complex number. When we can have a complex number that they said is 2 equal. The first one is that you are going to equate the real numbers and you are going to equate the imaginary part. Let's understand. Let's say we have I plus j4 equals to 5 plus j3. Then we should find x and y. Here, this one is going to be x plus j5 because of this. By comparing, x is going to be y, 5, y is going to be 3. So that's all. So the same way as this one is going to be minus 3, this one is going to be 6. That's all. And here as well, you're going to add this. You know, this one and plus this, they are more or less like the same thing. This one is going to be, and by comparing, this one is going to be 1. 7 plus this one is going to be 7. This one that has is going to be 12 by equating. So we have to solve it in form of some question set. Then you have like this. If this video is useful to you guys, please subscribe and like and give us a good recommendation so that we are going to improve in the next video.